Hey, Mr. Loggery here. Okay, this is going to be a third quarter review. It's going to be a long video. We have 9 weeks of material to cover on here. I'm going to go through pretty fast, but you can just pause, skip the things if you need them. There's going to be a wide variety of topics, so just use whatever you need to work your problems you're working on. Okay, first off, we're going to look at characteristics of linear functions. That sounds difficult. All it means is we want to know if it's a line or not. Does this function make a line when we graph it, when we look at it? It should be a straight line that goes in both directions for infinity. So a graph is pretty easy. You just look at it and see if it's a straight line or not. It can't bend, it can't turn, it can't curve. It has to be a straight line. The table's a little trickier, but it's not bad. You look for what is called consistent change with the y and the x. So all you do is come look over here. From 8 to 6, that's getting smaller by 2. From 6 to 4, smaller by 2. 4 to 2, smaller by 2. All the way down, if that stays the same, always check your y's first. Normally those will be the ones that are different. It can be the x's, but it's most likely going to be in the y's. So it's just faster. If you find any two that are different, automatically stop right there. It's nonlinear. If it stays the same, this is getting bigger by 1 on the x's. Bigger by 1. Bigger by 1. Bigger by 1. If both sides are the same, it's linear. You cannot have one that doesn't match, so they all have to be the same. The y's have to stay the same and the x's have to stay the same. Okay, so let's look at graphs. We're looking for, is this a line or is it not a line? This is obviously not a line. See how it curves around? This is nonlinear. Okay? Let's look at the next one. Is it a straight line or is it not? This is a straight line. It's going forever. This is linear. Okay? So let's look at these. This one, it looks straight, but it bends right there. If it does that, it's non-linear. Okay? It has to be a straight line in the same directions. Straight up and down like this, that is possible. That's linear. They can be horizontal or vertical. This looks like the square root function. It kind of curves there. If it curves at all like that, we're looking at a nonlinear function. Now let's look at some tables. Start with the y's. That's normally where the variance will be, but not always, but most of the time, so it can save you time. This is going down 3, down 3, down 3, down 3, and I just keep going until I find one that doesn't match. Plus 1, plus 1, it's getting bigger by 1, bigger by 1, linear. Let's look at this one. That's going down 14, down 2. Automatically, I know it's nonlinear. I don't even need to go any farther. As soon as 2 of them don't match, you're dealing with a function that curves or bends. So let's look at this one. Plus 1, plus 3, non. Plus 1, plus 1, 6, 7, 8. All those are plus 1. 20 to 29 is plus 9. 29 to 40 is plus 11, non. This is going down by 10s, 55, 45, 35, 25, 15. Those are all down by 10. 1, 2, 3, 4, 5, plus 1s. This is linear. Okay, whenever you're looking at an actual function written as an equation, here is most of the time you're going to have it in this type of format. This is called Slope-Intercept Form. It doesn't have to be in this, but the trick is there needs to be one x, okay? There's a couple of exceptions, but there should be one letter x. If that's the case, it's linear. If you have an exponent on the x, if you have a square root on the x, anything like that, you're looking at a nonlinear function. There are a couple of exceptions to this, okay? We need to look at lines that have a zero slope or a undefined slope. That means a straight up and down line or a perfectly horizontal line. Those will be written like this. The horizontal ones, it's y equals 3. Y equals some number. That means the slope is 0, so you had something in the middle where it's like 0x plus 3 is how that would look if it was written out. The x is still there, it just goes away. So any line you see where it's just y equals something, that's linear. If you have x equals and a number here, it can be any number, I'm just choosing 3. That's a vertical line, and that's also linear, okay? Those are the exceptions. They don't happen that often, but they do happen. Most of the time you're going to have one like this, and if you see one x in there, that means it's changing by the same amount every single time, and it's going to be a line. If you see any exponents, any square roots, cube roots, if you see the square root sign or an exponent, a little number, you're dealing with the nonlinear function, okay? Now let's move to scatter plots. A scatter plot is just where you take two things, compare it together, and then you plot all that data out on a graph, okay? I'll show you what that looks like here in a second. They're made from plotting pairs of numerical data on a graph. Most of the time you'll have values from a table. We do this to help us figure out if there's a correlation, if those two things have a relationship or not, if they affect each other, okay? Sometimes they do, sometimes they don't. That's called correlation. Sorry, let me go back for a sec. That's called correlation when they do have a direct effect on each other. Okay? So let's look at this example. Down here we have the average daily temperature. That's like how hot it is outside. Over on the other side, over here, we have the number of visitors to the beach. We can probably just think this through and figure out what type of an effect that will have. But it's plotted out for us, so we're going to look. Do you see how it's kind of going up? Excuse me. There's a basic pattern there. These numbers are going up as we go across. If we look at this, this is 82 degrees right here. We had about 100 people at the beach. When it's 84, we had 225 people at the beach. When it's 85, 300, and then like 360 maybe right there, okay? This one at 87, it's right over here. It did drop down quite a bit. It looks kind of different, but you never know. Maybe it rained that day. Maybe there was a shark attack. Maybe there was something going on at the beach, some kind of event and the beach was closed down for a little while. You have to think through that type of stuff when you're looking at your data. So always look at your graph and see what clues it's giving you. But this is a definite correlation, okay? And it's called a positive one whenever the X numbers get bigger and the Y's get bigger, then that's a positive correlation. And it makes sense to us. So let's look at this. When X and Y both increase, this is kind of a formalization of what we just talked about. There is a positive correlation. So you'll have that up arrow like that, okay? You'll kind of see it. Sometimes it's tighter and sometimes it's wider and the dots are more spread out. But if that pattern's there, you have a correlation. And the correlations can be stronger or weaker, okay? Now let's look at when X increases. That means your number's going across here from left to right, if you're reading it from left to right. If your Y value is coming down, meaning X, as we go across X, these numbers are coming down over here. Do you see that? So you end up with kind of a down arrow. That's called a negative correlation. When it looks like someone sprayed machine gun fire all over your graph, there's just dots everywhere that don't make any sense, that is no correlation. Okay? So let's plot these points right here. A lot of times you'll be given a table like this one over here, and then you'll just plot the points, and then you'll see what type of correlation you have. So our first point is at 0, 95. So that's about here. I like to mark them off as I go. 388 is right about there, I think. 290 is around here. 583, probably about there. So you have to know how to plot your points. 779, looking at right up close to there. 970, 485 would be here. 194, right up here. 1065 and 875. So let's look at what we're doing here. This is absences versus final grade. So it's looking at how many absences a student had on the x-axis. Then it's looking at what their final grade was in the class on the y-axis. So what this graph is telling us, let me mark this over there, that's bothering me. So it's telling us how many times a kid was absent versus what their final grade was in the class. And as you can tell, someone who's here doesn't miss a day scored higher in the class. And as the x gets bigger, as our absences increase, the scores are decreasing. So that is a negative correlation. I'm just going to write it like that, but that's a negative correlation, and that makes sense, okay? If you miss a bunch of school, your grade probably goes down. So this graph makes sense to us. Another thing we can use these scatter plots for when we're collecting data, it's so that we can predict things. We can try to guess the future with them. So let's look at this. Describe the relationship between absences and final grades. We just did that. The absences, as the absences increased, the grades decreased, right? Decreases. So that's what we figured out. And it was a negative correlation. Now you may see a question like this. A student has been gone for 6 days. Predict her final grade. What we're going to do is we're going to go on our graph and we're going to look at where the absences are. And they're on the x-axis. We're going to find 6. Then we're going to follow it up. Let's go up here. And we're going to look about where it would land on our line. And I would say probably right in here, right? That would complete the arrow going through. It's going to be somewhere in this range right here. So I just put it on that so it's easy to find. So that's our prediction. So we're going to go across right here. And we're going to look at right about what we think their grade would be. And then we'd say, oh, they probably will score around an 80% in the class. It may not happen. Maybe they're a genius. Maybe they worked hard. Other things, you can have things that don't line up. But this is about the best prediction we can make right there. Okay, let's move to lines and tables. Excuse me. It says complete the table of values using the given function, then plot the points on the graph and draw a line through the points. So what we do anytime you have a function like this, for us, we're using linear functions, but it can be any type of function. You're going to see them all through high school and college. It means you take an x value, you plug it in, and it spits out a y value, okay? So we're going to take these x values, put them up into our function, and it's going to give us out what goes in the y. So for this first one, x is -2. We're going to go y equals 2. We're going to substitute in a -2 where x goes, because if x is -2, then we can just put it in for it. Plus 4. This is going to give us -4 plus 4, which is 0. So when x is -2, y is 0. And then we're just going to repeat. You can do this in a calculator if you need to. And you just go to the next x value. This is going to be negative 2 plus 4, which is 2. At this point, because we're dealing with linear functions, we remember from the first part that this has the same pattern. So you can keep going and putting in your x's and seeing what it gets, or you can say, oh, this is going up by 2 each time, so this is going to be 4 and 6. Because all of these have to stay the same. Either way you can use to fill out the function table, whatever you want. Then it says to graph it. So all you're going to do is take these points, because that's all this table is just a set of points that fall on your line, and you're going to graph them. Negative 2, 0 is right here. Negative 1, 2 is right here. 0, 4 is here. 1, 6 is here. And then you just try and draw your line as straight as possible, and that's your line. So the line y equals 2x plus 4 looks like this when you graph it, okay? Why don't you pause this one, see if you can do it, and then we'll work it, okay? All right, don't freak out when you see a fraction over here. We're still going to plug these x's in, all right? Y equals negative 1/2 x. So we're going to put in a negative 2 for that, plus 3. Y equals negative 2 times negative 1/2 is 1, positive 1, plus 3 is 4. So this is a 4. Y equals negative 1/2 times 0 plus 3. The zeros are the best because this just zeros out. 0 plus 3 is positive 3. And now we can tell we're going down by 1, so this is just 2 and 1 right here. And then we graph it. Negative 2, 4 is here. 0, 3 is here. 2, 2 is here. 4, 1 is here. And then we graph the line. I didn't draw it very well, but your line should travel through all your points. So draw your line better and straighter than I did, but this is the main idea right here. This is this line when you graph it. Okay? Now it says to find the value of y when x is 3. This is the same thing we just did with the function table. All you do is put this 3 in for x and solve it, and it'll tell you what y is. So y equals negative 4 times 3 plus 8. This is y equals negative 12 plus 8. Y equals negative 4. There's your answer. When x is 3, y is 4. This would be how your point would be written if you need to write out in an ordered pair. All right, let's do another one. When x is 9, what is y? Just plug it in. Y equals negative 5 over 3 times 9 minus 4. Y equals, that's negative 45 over 3 minus 4. Negative 45 over 3, that's negative 15 minus 4. Y equals negative 19. You can put all of this into a calculator. Well, this part, you can plug into a calculator. It'll do it for you if you plug it in right and use the negative sign correctly. Okay, now this one, we're doing the same thing from a graph, and you've already been doing this, so you should know how to do it, okay? It's the same process. When x is 3, go to the x-axis, okay, and find 3. Once you find that, go up or down. Sometimes it can be down here, but not on this one. We're going up. Go up until you find where your line is. This is where your line is when x is 3, okay? To find what y is there, just come right over here across and see what it is. Y equals 5 on this one, okay? Pause this one, see if you can do it. Okay, this time we want to know y when x is negative 2. We're going to go to negative 2 on the x. This is where our line is. I'm going to come right here. Y equals negative 1. Find the value of y when x is negative 3. X is negative 3 right here. Here's my line. Come on over. y is negative 4. They just take some practice and you'll have this down in no time. All right, now we're going to find the value of y when x equals 4 from a table. Well, this is pretty easy right here. Go look on your table. Figure out, here's x, see where it's 4. Whatever y is, that's your answer. Y equals negative 7. Okay, these are just, they're paired up together. So you just need to find the set that matches. Find the value when x equals 2. X equals 2 here, y equals negative 3. Go ahead and pause the video. See if you can figure this one out. It's a little more challenging. Okay, x equals 6. You may have noticed in your column, we don't have a 6 over here, but we do know that linear functions follow a pattern, and these are getting bigger by 2 every time. So I know that my next number here is going to be 6. And I also know my y's follow a pattern. This is getting smaller by 4. So if I do negative 7 minus 4, now I have my answer. When x is 6, y is negative 11. Excuse me. All right. When x is 0, here's x, here's 0, y is 1. Easy enough. When x is 15, oh boy. So let's look for the pattern here. Plus 3, plus 3. So this is going to go 9, 12, 15. Now I got the number I want. These are going plus 5, right? Plus 5, plus 5. So if I go plus 5, I'm going to 16, and then 21, and then 26. So when x is 15, y equals 26. Okay, let's talk about x and y intercepts now. The x-intercept is the ordered pair or point on a graph. An ordered pair is a point, okay? This is where your function line, the line you're graphing on there, where it crosses the x-axis, the one that goes sideways. The y value of the x-intercept is always 0. What that means is your point, if it's in ordered pair, is going to look like this. You will have a number in here for x, and you'll have a 0 for the y. And that makes sense. We'll look at that more here when we see a graph in a second. The y-intercept's the opposite of that. It's where your function line crosses the y-axis. And the x value is 0 on that one, and the y value has a number in here. So let's see what this looks like. On this one, the x-intercept is negative 5, 0. That's because it's right here. You see our red line crosses the x-axis. This is the line running this way. It runs sideways. This is where our line crosses. That's the x-intercept. And then you write it like that, the way you would plot it. It's negative 5 and y is 0. Any number that falls on this axis is going to have a 0 for y because it's not moving up or down. So that's always the case. And then it's the opposite for the y-intercept. So this is the y-intercept, and you can see we've got it written 0, negative 4. It's right there, because that's where we cross. And any number that falls on this is going to have an x value of 0 because we're not moving left or right. Okay? So let's solve some of these. What is the x-intercept of the graph and the y-intercept? Let's do x-intercept first. We can look at it and see it's right here. We can see it falls on the number 3. So we know we're going to have a 3 here and a 0 for the y. Now the y-intercept right here, we can see that's at negative 5. We have a 0, negative 5, just like that. Let's do on this one. Let's do the x first. It's right here. 4, 0. The y-intercept, 0, 4. Look at that. They're the same number, just at different spots, positive 4. Okay. What's the x-intercept of this one? Oh, it's the same as the y, right? It goes right through the middle. When that happens, your point is 0, 0 on both of them. Okay? Let's look at this one, the x value and the y-intercept. The x value of the y-intercept is always 0, I should say. It says find the x and y-intercept. So the x is here. The x is going to be, x-intercept is 5, 0. The y-intercept is right here at -2. So we have 0, -2. All right. When you have it in slope-intercept form like this, where you have y equals mx plus b, we'll talk about this in a little bit. The reason we have this form is because it's really easy to see. Your slope is whatever's in front of the x. Your y-intercept is this constant on the end. So the y-intercept is really easy to find on these. The y-intercept is -8. So you have 0, -8. The x-intercept is a little trickier. What we can do here is we know that the x-intercept, so that should be a dash, has a 0 for y and a number here. Well, if we know that y is 0, we can come up in here and put in a 0 for y and solve it. And that'll tell us what x is right there. But we got to solve this first. We have to use our algebra. We're going to do +8 on both sides. 8 equals -2x, because that canceled. Now we divide by -2. -4 equals x. So the x-intercept, when y is 0, x is -4. And that's how you solve for that one. Okay? So the y-intercept's easy when you've got this form, but the x-intercept, you got to do a little bit of work for it. Okay, let's talk about slope. This trips a lot of people up. The slope is the measure of how steep a line is. If you think about hills, mountains, a ramp, things like that, you see how you're going up as you travel across them? This is a way that we try to measure these, okay? We're measuring how steep it is. So the higher the slope, the steeper the line. That means the bigger the number gets, the steeper it is. So at one going way up like this, sorry, I'm not very good at drawing like that. That's going to have a bigger number than one that's going up like that. Same thing here. This is going to be a lot steeper than one that's going down like that, okay? Slope is always the letter M when you see it, okay? I don't know why, that's just why it is. So we're going to look at these and put them in order of the steepest from least to most steep. So pause the video and see if you can do it, and then we'll go over it, okay? So it looks to me like the least steep is probably letter D right here. And then after that, probably B, and then E, and then it looks like A next, and then C. So D, B, A, E, A, C. You got to kind of get used to looking at your lines. Look at them anytime you see one on a graph and just kind of make a mental note every time. Is this positive or negative? How steep is it? That's what my slope number should reflect that. And if it's off, I probably did a calculation wrong. So when you're going up from left to right, always read your graph left to right. It's positive. Another way to do this is find the left side. Pretend that you're signing your name on the line. If your pencil's moving up, it's positive. If the line goes down from left to right, or if you're signing your name and you're going down, it's negative, okay? It's really important to be able to tell these apart. Sometimes it's easier, sometimes it's not so easy when they get really steep or really flat, but you got to be able to try. So the slope, what it is it's a ratio. It's called a rate of change. And you're taking the change in your y value, so that's how much you're moving up and down, and you're making it a fraction, and you're dividing it by how much the x is changing, and that goes left to right. So you're looking at vertical change divided by the horizontal change. This is also called rise over run. So it's really kind of like an average. It's how you track how the line is changing. If it's changing a whole bunch in one direction, it gets steeper or flatter. And we'll look at that in a second, see, okay? So let's look first at a line on a graph and how to find the slope. So if we're doing this triangle right here is delta, it just means change. It's a Greek letter, okay? So we're looking at change in y over the change in x, or the rise over the run. First thing I do is I look at my line. Is it positive or negative? This line's going up, so it's positive. That tells me that when I start to count, I need to count up first, because when you count up, it's positive, and when you count down, it's negative. So you need to be able to find points of intersection. What that means is, do you see these little cross sections here where the horizontal and vertical lines cross each other? You are looking for points where your line crosses those, and that's where you make your points. If it goes through the middle of something, you don't count it. So what that looks like is, if I follow my line across, there's one here. You see where this blue line is crossing right through the intersection. And then I go a little bit farther, and then there's one here. You need 2 points. Then we know our line is positive. We need to get from point to point, so we're going to count up 1. You see I went up 1 unit. I went across 1 square. And then I went right 2, because I went 1, 2. Then I take however many I counted up or down, and I make a fraction. That goes on the top. The number I went sideways goes on the bottom. And then you reduce your fraction. 1 over 2 is already reduced. So this has a slope of 1/2. And that makes sense. It's a smaller number. 1/2 is smaller than 1, so my line is fairly flat. Now let's look at this one. First thing I do, this is a positive line, which means I'm going to count up when I do my rise. So now I'm looking for my points on it. I can see there's one here. Follow, and there's one here. These should be evenly spaced apart. There's also one here. I'm going to start at my first point and go to the second. You can count to any 2 points, but if you choose the 2 closest together, it's easier, and you don't have to reduce a fraction as much. So I'm going to go up 1, 2, 3, 4. I went up 4. I went across 4 squares. I went right 1. So my slope is 4 over 1, which reduces to 4. And that makes sense. It's a positive number, and it's a pretty steep line. The bigger that number gets, the steeper your line gets. Now let's look at this one. This is a positive line. I got a point here. I got a point here. I'm counting. I went up 3, right 2, 3 over 2. That's already reduced. That's my slope. Excuse me. Now let's look at a special case, okay? I can see I have points, and it's a horizontal line. Whenever I go to do my rise, well, I don't go up or down on this one, right? So my rise is 0, and I'm going right 1, so my run is 1. 0 over 1 is 0. Slope of 0 is a horizontal line, okay? Any line you see that's going, it has to be perfectly horizontal. It's going to have a slope of 0. Now let's look at a vertical line, and you're probably thinking, oh, I know the slope on this one already. It's 0. Well, let's look closer. So whenever we go to do our rise and run, when we can do a rise, we get 1. We go up 1, but we are not moving left or right. So we're going 0 down here. Here's the thing in math. You can do 0 divided by 1. That's 0. You can divide 0. Nothing goes into it. You cannot divide by 0. It's not 0. The answer is not 0. It's undefined, because that's impossible to do. You can't take nothing and divide it into something. So a vertical line has a slope that's undefined. You can just memorize that if you want to, because you'll have a bunch of these. If it's horizontal, it's 0. If it's vertical, it's undefined. Most of the time, you're going to have a different line, and it's going to have a slope, okay? And it's going to have a regular number for a slope. Now let's look at slope-intercept form. This is y equals mx plus b. You have to remember this. This is going to be used for every math class you take from here on out. M is the slope. We already talked about that. B is the y-intercept, okay? So let's look at what that looks like. Y equals mx plus b. We want to write the function of this line in this form. We want an equation for it. So we know the m goes in front of the x, so we need to find the slope and put it here. We need to find the y-intercept and put it here. I do the y-intercept first because it's easy. I can look and see where I cross the y. It's at 2, right? So I know that's a positive 2 right there. Then I know the slope. We find it the way we just did. Here's a point of intersection. Here's a point of intersection. Up 3, right 1. My slope is 3 over 1, which reduces to 3. I just go put that in. So y equals 3x plus 2. That's how we would write the equation of this line. Pause this one. See if you can do it real quick. And then we'll look at it. Okay, so I need slope and y-intercept. Slope first, or y-intercept first, -4. Easy enough, right? Can see my line's negative. I'm going to have to count down when I count. Here's a point of intersection. Here's a point of intersection. The line's negative because it's moving down from left to right. If I try to write my name, my hand's going down. When it's negative, you count down first. This is down 2, which gives me -2, right 1. Slope is -2 over 1, which becomes -2. Y equals -2x plus -4. You can also rewrite this as y equals -2x minus 4. I accept it either way, but in the future you are expected to simplify this. When you add a negative number, you're subtracting. Now let's look at it from a table. We can do it the same way, okay? Only this time, we need to know how to get the y-intercept from our table. Well, we already know a y-intercept is structured like this, right? We have a 0 for the x, so let's go find where x is 0. Well, what's y right there? That's the y-intercept, okay? Now let's find our slope from this table. We are going down 5, down 5, down 5. We only need one of these to find the slope. This is going up 2. Well, here's your rise. Here's your run. -5 over 2. The y's always go on top, okay? Because that's the rise. You're moving up and down. The y-axis runs up and down. So that's why the difference in the y's goes on top. That's how many you would count down if you're doing it on the graph. This is how far you would count to the right. So the slope is -5 over 2. So y equals -5 over 2x plus 9. See if you can do this one real quick. All right. Horizontal table, same deal. Change in y. You only need 1 point or 2 points. You need to find the difference between 2 points, okay? That's going up by 4. This is going up by 1. So slope is 4 over 1. The y's go on top, which is 4. Y-intercept, wherever x is 0, y is -8. Y equals 4x minus 8. Just like that. There's your equation. Okay, now let's look at our 2 special cases. These are the ones that write really weird, okay? Let's do horizontal first. We already know that a horizontal line has a slope of 0. So this is going to be y equals, and we know it's 0x. And then the y-intercept is -3, right? Well, when you multiply 0x, 0 times anything is 0, you get 0 minus 3. So anytime you have a horizontal line, it's written in this form. I went over that a little bit earlier, okay? If you see y equals a number, that means you have a horizontal line at whatever that number is on the y-axis. This one's y equals 2. Okay? Vertical lines are a little trickier. They are written as x equals, and then you do whatever this number is. That line right there is x equals -5. X equals 2 would be right here. Vertical line right there. Okay? And that's all you do for those. So let's see, how would we graph y equals 2? Well, we just did that one, didn't we? That's a horizontal line here. When it says y equals, that means you got a 0 slope. X equals -4. It's going to go right through -4 like that. Now, when it asks you for the slope and the y-intercept from equations like this, these are questions you better never miss when you're in slope-intercept form. Because we know m is just whatever number's here, y-intercept's here. Slope is 2, y-intercept's 7. Slope is -6, y-intercept's -1. Because we know slope sits in front of the x, y-intercept is the constant on the end. Okay, let's look at equations versus inequalities. All right, equations only have one solution. There's only one value for x that works, and they use an equal sign. You can also look up here, it's kind of a clue. It starts to spell out the word equal. In inequalities, there is more than one solution. That means there's more than one value that you can get for x. They use these symbols down here, greater than, less than, greater than or equal to, less than or equal to. When you graph an inequality, so let's look at this, okay? What does x is less than 4 mean? X represents all the numbers that are less than, smaller than 4. The way you graph that, this is where the 4 is right here. You circle that point on the number line. Everything to the left is getting smaller. Everything that goes right is bigger, okay? So if we want all the numbers less than 4, that's all these numbers this way. So you would shade your graph going this way, and it would look like that, okay? When you're graphing an inequality and you mark your number on the number line, if it is equal to, this means greater than or equal to, less than or equal to, you shade in the dot because that number is one of the solutions. If it says less than or greater than, you use an open circle like this. And you don't shade it in because that number is not part of it. It's either going to be all the numbers bigger than or less than that one. But that number is not part of it because it cannot be equal to it. So if we want to graph x is greater than or equal to 2, go ahead and pause this, see if you can do it. So we're going to circle at 2. This is where 2 is right here, +2. And then if x is greater than, when this opens up, that means greater than if it's pointing at the x, like that. So we're going to do all the numbers greater than 2, which all the numbers to the right of 2 are bigger than 2. It can also be equal to 2, so we're going to fill this in. Okay? What are 3 values for x that make this statement true? If it has something like that, any value that's in this red shaded area over here will work. Anything to infinity. So it can be 2, it can be 5, it can be 10, it can be 100. Any number bigger than 2 or equal to it. If we want to graph x is less than 1, we're going to circle the 1. All the numbers less than 1, but it cannot be equal to 1, so we leave this as an open circle right here. 3 values for x that make this statement true, anything over here, -5, -2, -1,000. Any number that falls in the shaded area. So now let's look at solving one-step inequalities. So we're going to look at it as an equation and over here and an inequality. So normally for an equation, use your algebra. You're going to cancel this 9, positive 9 by doing negative 9. That cancels x equals 5. For an inequality, you work it just like you do with algebra for an equation. You still get rid of this constant. It's plus 9, so we're going to do minus 9 to zero that out. If you do it to one side, you got to do it to the other side. That cancels x greater than 5. Same thing here. Anytime we have a number next to x or a variable like this, that means they're multiplying, so we need to divide to undo that. So we get x equals 7. Same thing with the inequality. You just divide 5 on both sides. X less than 7. Okay, now let's look at this one. Same thing as last time. This is multiplication, so we're going to divide. X is less than negative 8. Now we're going to divide by negative 7 on both sides. Here's the one difference that you have to remember. Those cancel. We get x. You still get negative 8 over here. But if you multiply or divide by a negative number, when you're doing an inequality, you have to flip the sign around. It has to be done on both sides. Not over here where this number was negative. We divided by a positive number on both sides. It has to be a negative number on both sides, and it's either multiply or divide. If that happens, you flip your sign. That's the only difference between doing algebra on equations versus inequalities. So now let's look at solving two-step equations. Remember, equations have an equal sign. You undo, you're going in the reverse order of PEMDAS, where you do parentheses, exponents, multiply, divide, add, subtract. Excuse me. When you're undoing that to work backwards on a problem to cancel everything around the x, you do the addition and subtraction first, and you're going to do the inverse operation, the opposite operation to cancel it. And then you do multiplication and division next, okay? Let's look at this two-step equation. We're going to go to the side the variable's on. The x is over here. We find the constant. It's plus 7 here. We're going to do minus 7 on both sides. That cancels. We get 2x. 11 minus 7 is 4. Now we divide by 2 on both sides, and x equals 2. Pause the video, see if you can do this other one. Okay, this is a positive 12, so we're going to do minus 12 on both sides, and we get 12 equals negative 4x. Now we divide by negative 4, and you get negative 3 equals x, because that canceled and those canceled. Now we're going to look at solving two-step inequalities. You do the first two steps, you do them the exact same way. The only difference is, remember our rule we talked about, if you multiply or divide by a negative number, you flip the inequality symbol. Okay? So let's look at this. We're going to do plus 2, like we've been doing all year, no problems. 3x is less than 42, divide by 3. Divide by 3, x, and this is 14. These are both positive, so we don't do anything different. We keep the symbol the same. And that's our answer right here. This one, we do minus 16. Minus 16, you get negative 3x, greater than or equal to 6. Now we're dividing by negative 3 on both sides. Here's your rule. You have to flip the symbol around because we divided by negatives on both sides. See if you can figure these out real quick. These are multi-step equations. If you don't remember how to do these, what you do is you simplify everything on each side of the equal sign as much as possible, and then you solve it, okay? So I can already tell on this one, we have a couple terms right here that we can combine. When you combine like terms, you can combine everything that's the same if it's a variable or if it's a constant. So we have 2x and 4x, that becomes 6x minus 5 equals 31. Now it's a two-step equation. We can solve plus 5, 6x equals 36, divide by 6 on both sides, and you get x equals 6. Over here, I can already tell we've got distributive property. Anytime you see parentheses like this and a number on the outside of it, you need to distribute it through. You multiply everything through. So 5 times x, 5x. 5 times 35 is positive 35. Everything else stays the same, and now we work it like a normal problem. A two-step, minus 35, minus 35. 5x equals negative 15. Divide by 5, x equals negative 3. All right, pause the video. These are just like the last one. See if you can work them. And then come back and see if you got it right. Okay. This time we have two constants that we can combine. So this is going to be 7x minus 9. Negative 11 plus 2 is negative 9. And now we solve it like normal. 7x equals 35. Over here, we have distributive property. Negative 2 times 3x is negative 6x minus 20. Negative 2 times 10 is negative 20 equals 4. And now we're solving it. We have a two-step equation we know how to solve. Just like that. Okay, solve a couple more. If you can't tell on this one, you have constants you can combine. This one is distributive property. Okay, so let's work this one. We have 10 equals 11 plus 7 is 18 minus 8x. And now that's a positive, so you use negative. To get rid of it, we have negative 8 equals negative 8x. Divide by negative 8, and positive 1 equals x. Use your calculator for any of this arithmetic you need to do if you're not sure about it. On this one, it's going to be 8 equals 2 times x is 2x. 2 times 11 is positive 22. Then we subtract 22, negative 14 equals 2x. Divide by 2, negative 7 equals x. Okay, now let's look at some multi-step equations, all right? You're still going to simplify both sides, okay? So the first step, simplify everything. So let's see, this one, x minus 5 is simplified. 12 plus 3 is 15 minus 4x. Now we have an issue. We have variables on both sides. We have an x on both sides. Cancel a variable. I'll show you how to do this. If you don't remember, you're going to cancel one of these x's. I always take the lowest one because then you're going to work with positive numbers on one side, but you can go either way and it will work out the same. I'm going to do plus 4x and plus 4x here, and that's going to give me, that's a 1x, so this is 5x minus 5 equals, now we've canceled that, and we've got 15, and now it's a two-step equation. Plus 5, 5x equals 20, divided by 5, divided by 5, x equals 4. Now, if you want to check that, plug this x in, back up into this original equation, and see what happens. We're going to get 4 minus 5 equals 12 plus 3 minus 4 times 4. This is negative 1. This is 15 minus 16. Negative 4 times 4 is negative 16. So negative 1 equals negative 1. Hey, look at that. Balances out. Let's kind of create some room over here. This one right here, I can see I have distributed property. I'm going to have x's on both sides, so I need to follow these steps over here. 11x plus 45 equals 2 times x is 2x, 2 times 19 is 18. Now I'm going to subtract 2x because that's the lowest one, but you can go any way you want. 9x plus 45 equals 18 minus 45. Minus 45 to cancel there. Is that negative 27, I think? Divide by 9. Definitely check these in a calculator. X equals negative 3. Okay, let's look at central tendency. So, this is mean, median, mode, range. The mean is the average, okay? That means you add everything up because you're going to have a set of numbers, and then you divide by how many numbers you have. Okay? The median is the middle. It's the number right in the middle of everything. The mode is the one that you have the most of. It occurs the most. So I'm going to put most numbers. And I'll show you what these mean, okay? These are the measures of central tendency, and they're used to describe the center or middle of a set of data. So it's taking a whole bunch of numbers and it's trying to figure out what is the very middle of that. What does it look like in the center of all those numbers? So the mean is the average. You find the sum of the numbers in the set, then you divide the sum by the amount of numbers in the data set. Okay? So first thing you do, add them all up. So we're going to do 14 plus 8 plus 10 plus 12 plus 5. I'm going to use a calculator because I don't trust myself, and I'm just going to add all of them up. And if you're using a calculator, add them all up and get that answer first, because you have to force the division to happen second. If you put it all on one line of the calculator and do it, it knows order of operations and it will divide first and then add everything up. So this is 49. Then I'm going to come over and count 1, 2, 3, 4, 5. I have 5 numbers, so I'm going to do 49 divided by 5, and you get 9.8. That's the mean. So to recap, add all your numbers up and then divide by how many numbers you have. Okay? The median is the middle number in the set. Here's the thing with median. You have to put it in order from least to greatest, okay? So you put it in order from the smallest number to the biggest. You figure out the number directly in the middle. The problem is if you have an even number of numbers, you're going to end up with 2 numbers in the middle, and then I'll show you what to do, okay? So first, let's do this one. Let's put it in order: 5, 8, 10, 12, 14. Obviously, in the middle of this one is 10, but sometimes you have really big data sets. You have a lot of numbers. The easiest way to do it is to get them in order and then start marking them out one at a time from each end. So I go 1, like that, and then I get my middle number. Okay, so the median of this data set is 10. But if you have 30 numbers, you can lose track real easy. It's hard to tell the middle numbers. Now let's look at this one. So we're going to put it in order first. Negative 12, negative 8, and then 5, then 10, then 14, then 15. So now let's start marking them off. 1 from here, 1 from here, 1 from here, 1 from here. Uh-oh, if I mark these, now I'm going to be in trouble because all my numbers will be marked out. If you have 2 numbers left for median, and this happens when you have an even set of data, Then you add these two together. You're really just finding the mean of these two, which is adding them together. And you divide by 2, and it's going to be 7.5. You're trying to find the midpoint between those two numbers. 7.5 is halfway between 5 and 10. So if you have a data set that's even and you have to find median, you have to know how to do that with the middle two numbers, all right? It's not too bad once you do it a few times. Now let's look at mode. This one's easy. It's the most repeated number, okay? So you're going to look at your data set. Look over here. Which number do we have the most of? We have 3 12s, so 12 is the mode. What about this one? I have 2 12s and 2 8s. You can have a tie. You can have more than one mode. So on this one, it's 8 and 12. How about this one down here? Nothing repeats, so you have no mode. Something has to repeat at least once to have a mode. And you can have a tie, but it's only the ones that have the most. If you have two numbers that have 3 and then two numbers that have 2, it's only the ones that have 3. It's only the ones that repeat the most. All right, let's look at it real quick. So we're going to find the mean, the median, and the mode. And then we're going to talk about what a range is. So let's do the mean first. We're going to add all these up. 3 plus 5 plus 4 plus 8 plus 2 plus 3 plus 6. 3 plus 5 plus 4 plus 8 plus 2 plus 3 plus 6. I'm doing on my calculator. Equals 31 divided by 1, 2, 3, 4, 5, 6, 7. 31 over 7, which is 4. It's 4.42857. It keeps going. I'm going to round to the nearest hundred, so it's 4.43. The median, I'm going to put these in order. Let's see, the smallest number is 2. Then I have 2 3s, a 4, a 5, a 6, and an 8. 1, 2, 3, 4, 5, 6, 7. Yep, we have 7. 1, 2, 3, 4, 5, 6, 7. 7 numbers. So I'm just going to start marking off. I have an odd number, so I should end up with 1 in the middle. 4 is the median. And then mode, well, I got 2 3s. Nothing else repeats, so the mode is 3. Now let's look at range. And what range is trying to tell you is how far the distance between the smallest and the biggest number in your data set. So that's what you do. You find the biggest number, and if you put them in order for median already, the biggest number should be on the right-hand side. So it's going to be 8, and then you subtract the one farthest on the left that's the smallest number. So this one's 8 minus 2, which is 6. So if we plotted this out on a number line and we looked at the distance between 2 all the way to 8 on the number line, then that whole distance all through here is 6. Okay, let's look at this one. Let's find mean. I'm going to abbreviate median, mode, and range. So let's do the mode first. That one's easier. We got 2 9s, so mode is 9. The range, we can take the biggest minus the smallest. 18 is the biggest, 6 is the smallest, so the range is 12. The median, and I could have put these in order if I wanted to and found the big and smallest first. If you have a huge data set, that's the smartest way to do it, and find the median first. But if you don't have that many numbers, you can easily choose the biggest and smallest. So now I'm going to put them in order. 6, 2 9s, a 10, an 11, 12, 13, 14, 15, 18. And then I always count 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers, then I count up here 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm good. So I'm going to start marking them off. Now I should end up with 2 in the middle. And it's 10 and 11, so I can tell halfway between that's 10.5. You can add them together. You get 21 divided by 2, it'll give you the same thing. And now for the mean, I'm just going to add them all up. I'm not going to write all that out, but I'm going to add it all up on my calculator. 14 plus 9 plus 15 plus 18 plus 6 plus 10. It's 92 over, how many did we have? We said 8 numbers, 2, 4, 6, 8, 8. So 92 divided by 8 is 11.5 for the mean. Okay, real quick, let's look at how to round numbers, because we need practice. This wants it rounded to the first decimal place. That's the 10th place. That means 1 decimal place, okay? And whenever you have your answer, it should be 1 number after the decimal point. All you do, you look to the right 1 number, okay, from where you're rounding. So if I'm rounding to the nearest 10th place, I'm looking to this one. It's a 3. If it is less than 5, this number stays the same. So this rounds to 4.1. If I'm looking here and that number is 5 or bigger, I take this number and I add 1 to it. So this rounds to 7.9. If it's a 5, you still round up. So it goes to 11.3. I add 1 to it. Okay? Let's look at vocabulary in a data set. Outlier. An outlier, these are easy to spot. It's any number that is significantly larger or significantly smaller than the rest of the data set. Let me show you what that looks like, okay? Look at this, pause the video, see if you can find the number that doesn't belong. Okay, in this one, 8, 10, 11, 15, 16, they're all pretty close. 40 is way bigger than all those. This is kind of subjective, okay? You can look at it kind of objectively, but it's best judgment, all right? The number has to look a lot bigger or a lot smaller than the rest. So now let's look at data set number 2. We have 50, 56, 48, 42, 60, 50. Be kind of easy to say, oh, look at 60, but really this 19 is way farther away. These are on the 40s, 50s, or 60 is close to the 50s. 19 is way below. On data set 3, this 212 is way bigger. And then whenever you're doing it on a graph, it's normally way easier to see, because if they're plotted out as points, the point will be way outside of the range of the correlation we looked at earlier. So let's look at this, inserting data points. So a lot of times you're given a question, you solve all your central tendency or one of the things, and then it wants you to add something in or take something out and then see how it changed. So if we're looking at this, what is the average amount of hours worked over 6 weeks according to the table? Well, we know how to do an average, and it even tells us there's 6 numbers here. So we're going to add these up and divide by 6. So 40 plus 41 plus 35 plus 42 plus 36 plus 34. 228 divided by 6. So I'm going to divide by 6, and I get 38 hours. If we added a 7th week with 45 hours, what would happen to the mean? And what would happen to the median? Okay, so let's go ahead. We know we had 228 when all these were added up, right? So if we just add 228 plus 45, that gives us 273, and that'll be the same as if we added them all over again. And now we have, if we added a new one in, we have 7. So let's look at 273 divided by 7 is 39. So what happened to the mean? Well, it increased. Right? By 1 hour. Now let's look at what would happen to the median. Well, to get the median first, the first one we have to put all the numbers in order. So we have 34, 35, 36. What's next? 40, 40, 41, 42. And we know we're going to be halfway between 36 and 40 is 38. So the original one is 38. If we add a 45 on the end and we mark off, then we end up with 40. So it goes from 38 to 40. It increased again, but this time by 2 hours, right?